sunset during civil twilight. It's a pinkish glow that surrounds the observer, extending roughly 10 to 20 degrees above the horizon. It appears opposite the afterglow, which it also reflects. In a way, the belt of Venus is actually alpenglow, visible near the horizon during twilight. Though unlike alpenglow, the sunlight scattered by fine particulates cause this rosy arch of the belt, and it shines high in the atmosphere and lasts for a while after sunset. This pinkish glow is due to the Rayleigh scattering of light from rising or setting sun, which is backscattered by particulates. The zodiacal light, which is caused by the diffuse reflection of sunlight from interplanetary dust in the solar system, is also a similar phenomenon. Since the greatest elongation or angular separation between the Sun and a solar system body, the one of Venus, is only about 45 to 48 degrees, the planet never appears in the opposite of the Sun's direction from Earth and is thus never located at the belt of Venus. Ice halos formed by the refraction of sunlight or moonlight in plate-shaped ice crystals that are suspended in the atmosphere, typically in actual cirrus or cirrostratus clouds. In its full form, the arc has an appearance of a large, brightly spectrum-colored band running parallel to the horizon. The distance between the arc and the sun or moon is twice as far as the common 22-degree halo. Often when the halo-forming cloud is small or patchy, only fragments of the arc are seen. As with all halos, it can be caused by the sun as well, but much more rarely the moon. The misleading term fire rainbow is sometimes used to describe this phenomenon, although it's neither a rainbow nor related in any way to fire. The term, apparently coined in 2006, may originate in the occasional appearance of the arc as flames in the sky when it happens in fragmentary cirrus clouds. In principle, certain oriented column crystals may also produce the arc, although this is rare, and the 90-degree inclination between the ray entrance and exit produce the well-separated spectral colors. The arc has a considerable angular extent and thus is rarely complete. When only fragments of cirrus clouds are in the appropriate sky and sun position, they may appear to shine with spectral colors. How often a circumhorizontal arc is seen depends on the location and the latitude of the observer. In the United States, it is relatively common, several times each summer in any one place. In contrast, it's considered a rare phenomenon in Northern Europe. Continuous cloud-like phenomena in the upper atmosphere of Earth. When viewed from space, they're called polar mesospheric clouds, detectable as a diffuse scattering layer of water ice crystals near the summer polar mesopause. They consist of ice crystals, and from the ground are only visible during astronomical twilight. Now, noctilucent roughly means night shining in Latin. They're too faint to be seen in daylight. They're visible only when the observer and the lower layers of the atmosphere are in Earth's shadow, but while these very high clouds are still in sunlight. They are considered to be the highest clouds in Earth's atmosphere. They're located in the mesosphere at altitudes of around 76 to 85 kilometers. Data suggests that noctilucent clouds require water vapor, dust, and very cold temperatures to form. The source of both the dust and the water vapor in the upper atmosphere are not known with certainty. The exhaust from space shuttles in use between 1981 and 2011, which was almost entirely water vapor after the detachment of the solid rocket booster, was found to generate minuscule individual clouds. It remains unclear whether their appearance had anything to do with a volcanic eruption or whether their discovery was due to more people observing these spectacular sunsets caused by the volcanic debris in the atmosphere. But after the ash had settled out of the atmosphere, the noctilucent clouds persisted. Finally, the theory that clouds were composed of volcanic dust was disproved by Malzev in 1926. In the years following their discovery, the clouds were studied extensively by Otto Jesse of Germany, who was the first to photograph them in 1887 and seems to have been the one to coin the term noctilucent cloud. Systematic photograph observations of clouds were organized in 1887 by Jesse, Forrester, and Stoltz, and after that year, continuous observations were carried out at the Berlin Observatory. Seen before sunrise is a faint glow of diffuse sunlight scattered by interplanetary dust. Brighter around the sun, it appears in a particular dark night sky to extend from the sun's direction in roughly a triangular shape along the zodiac and appears with less intensity and visibility along the whole ecliptic. Zodiacal light is very faint, often outshined and rendered invisible by moonlight or pollution. The Pioneer 10 and Helios spacecraft observations in the 1970s revealed zodiacal light to be scattered by the interplanetary dust cloud in the solar system. Analysis of images of impact debris from the Juno spacecraft shows that the distribution of the dust extends from Earth's orbit to the 4-to-1 orbital resonance with Jupiter and suggests that it is the dust from Mars. However, no other dedicated dust instrumentation on Pioneer 10, 11, Galileo, Ulysses, and Cassini found an indication that Mars is a significant source. The Islamic prophet Muhammad describes zodiacal light in reference to the timing of the 5 daily prayers, calling it the false dawn, and practitioners of Islam use Muhammad's description of zodiacal light to avoid errors in determining the timing of daily prayers. This zodiacal light appears as a column, brighter at the horizon and tilted at the angle of the ecliptic. This light scattered from extremely small dust particles is strongly forward scattering, although this zodiacal light actually extends all the way around the sky, hence it's brightest when observing it at a small angle with the sun. Thus, it is possible to see more of the width at small angles towards the sun, and it appears wider near the horizon, closer to the sun under the horizon, or shaft of precipitation that evaporates or sublimates before reaching the ground. At high altitudes, precipitation falls mainly as ice crystals before melting and finally evaporating. That's often due to compressional heating because air pressure increases closer to the ground. Virga is very common in deserts and temperate climates. In North America, it's commonly seen in the western United States and the Canadian prairies. It's also very common in the Middle East, Australia, and North Africa. Virga can cause varying weather effects too, because as rain is changed from liquid to vapor form, it removes significant amounts of heat from the air due to the water's high heat of evaporation. Precipitation falling into these cooling downdrafts may eventually reach the ground. In some instances, though, these pockets of colder air can descend rapidly, creating a wet or dry microburst, which can be extremely hazardous. This fairly rare phenomenon, a heat burst, also tends to be of exceedingly dry air. Virga also have a role in seeding storm cells. That's because small particles from one cloud are blown into neighboring supersaturated air and act as nucleation particles for the next thunderhead cloud to begin. The word is derived from the Latin virga, meaning rod, sprig, staff, branch, shoot, twig, spray, sprout, switch, or graft.